Hello everyone. Today I will present SSLINT, a tool designed to detect misuse of SSL TLS APIs in real-world software. Hello everyone, my name is Shaw and today I will present SSLINT, a tool designed to detect misuses of SSL or TLS APIs in real-world software. And I will guide you through the problem, methodology, and result and conclusion of this study. So here is today's outline. First, we will cover the background and the introduction. And then I will discuss their methodology to detect the misuses and how they implemented their algorithm. Yep. And then I will show their result and finally conclusion. Okay, so let's start with the background and the introduction. I will first introduce the SSL and TLS handshake. So SSL and TLS protocols are the backbone of internet security. They enable confidentiality, integrity, and authenticity in communications using public key infrastructure, also known as PKI, and also asymmetric encryption. The handshake process established a secure connection by exchanging certificate and keys. And certificates follows the X509 format and validate critical information like hostname, issuer, and expiration date. And here you can see the process of the handshake. After a TCP handshake, the client will initiate a client hello message, which is also a request for the TLS or SSL connection. And after the server receives the hello message, it will respond back. Server hello, and also the chain of the certificate, and also the server's public key, and server hello done message. And after receiving those responses, the client will take its last step to finish its part by sending client key exchange, change cyberspec, and finished message to the server. And the server will do the similar things to finish the connection. And the client, after receiving the chain of certificate, it can start to validate if the public key of the server is valid. Okay, so here is a screenshot of one of the handshake message, which you can see there are some certificate being transmitted, and they all follow the X509 format in this case. So you can see there will be hostname, issuer, expiration date, and etc. But despite its security features, SSL and TLS is prone to vulnerabilities like man-in-the-middle attacks. In these attacks, an adversary intercepts communication between a client and server, leading both parties to think they are communicating directly to each other. But however, they are actually connecting to the attacker. So as you can see, the attacker can intercept the traffic from the user and impersonate the server by building another connection with the actual server. And the reason why this can happen is because it often utilize incorrect certificate chain validation. This can include expired certificate, unmatched issuer, or invalid certificate authorities. Yeah, so as you can see, this is the field in a certificate. And also, another common flaw is hostname validation. Attackers use DNS poisoning to redirect clients to their server, present a valid certificate for their domain, and intercept data as the client fails to verify the hostname properly. Which means that after poisoning the DNS record, just like these pictures show, the attacker can redirect the traffic of the client. And since the attacker also has a valid certificate, it can deceive the client that I am someone that authorized by the CA, which you trust. But however, its IP address is totally not matched with the actual server. Let's see the details. So first, attackers use DNS poisoning to redirect the client's traffic, and then the attackers present a valid SSL certificate, and client fails to verify the hostname, and it will trust the valid certificate provided by the attackers. Therefore, client accepts the connection, allowing the attacker to intercept the data and also do the encryption and decryption. Okay, next, let's see how this would happen. So this all begins from software implementation, which is misuse of APIs. Many vulnerabilities arise from poor software implementation and misuse of SSL APIs. Developers often neglect rigorous validation steps, making applications susceptible to attacks. Like this C code, there isn't any certificate validation function call in this code, so it will make this SSL connection vulnerable. Then let's see what correct use of APIs will look like. To prevent vulnerabilities, correct API usage is critical. Validation must be completed before initiating SSL read or SSL write operations. This ensures all checks are done before data exchange, just like this to C code. So there is a setup for the verification, and when they are doing handshaking, this function code will automatically check the validation of like hostname and the chain of certificate. And in this code, we first start handshake and get the chain of certificate from the connection, and then verify its validity. Okay, so this is the introduction of this paper. Here is where SSLINT comes from. SSLINT is a static analysis tool that detects API misuse by leveraging program dependence graphs, which is PDGs. It automates large-scale software analysis and enabling developers to identify and fix vulnerabilities efficiently. Okay, so they present an algorithm called SSLINT, which can detect the misuses of SSL or TLS APIs misuse. Okay, so they analyzed over 200 popular software packages on Ubuntu, and they found 27 misuses. Okay, next, let's see the methodology and implementation. Okay, to analyze an application, we need to first find the candidate software and their source code, and then define what's the correct use of APIs, just like the source code I just presented. And the third step is to build the analyzer. and then input the source code. And the final step is to analyze the result, just like this figure shows. So the first step, find the candidate. To find candidate, SSLINT use package managers like apt to list dependencies and check software using SSL libraries such as OpenSSL or GNU TLS. And the source codes are then retrieved and filtered to include only software actively calling SSL APIs. Just like these two comments, we will first see the we will first build its dependencies before we install the package, and then we get its source code. Next is to define the correct use. So correct API usage patterns are defined. For example, SSL and TLS read or write operations should only occur after validation check. These patterns are modeled as program dependence graph for automated analysis. So as you can see, this is the PDG, and the reason why we don't use like regular expression to detect all the string is because regular expression will be very hard to check the data flow, and also if you want to check all the valid usage, you will have to code down a lot of regular expression, because there might be various implementation of SSL code in the open source software. Okay, so we will have two correct usage. The first one is to retrieve chain of certificate after the handshake and see if they are valid, and the other one is to set up the parameter for verification before the handshake. And the graph referred here is the nodes and edges graph, not the image. And this graph can be stored in database to query, like using certain script to query all the like element, this node of a graph data. Okay, next is to build analyzer. So the analyzer uses tools like code server to generate and query PDGs. Custom scripts are written to automate the process, ensuring scalability for analyzing large repositories. Source codes from candidate software are input to the analyzer code server, process this code, and generating PDGs and identifying patterns of misuse automatically. And the script looks like these three. So we will first query the session, and then we will examine if the session maintain any types of correct usage. Okay, and now let's look at the results. So SSLINT analyzed 381 packages from Ubuntu 12.04 repositories. Among these, it identified 27 zero-day vulnerabilities, and it highlighted the widespread of misuse. The vulnerabilities found spanned various software types, including mail server, web browser, and database client. Each identified issue could lead to data leaks or man-in-the-middle attack, emphasizing the importance of SSLINT. So as you can see, these are the packages that were detected of misusing the APIs. And this page, we will see the data compromised by these vulnerabilities range from email content and user credentials to sensitive database information. SSLINT not only identify these risks but also provide actionable insight for mitigation. Okay, so these are the compromised data if those developers didn't fix the issue. Okay, so conclusion. In conclusion, SSLINT is a novel tool for detecting API misuses. Use of PDGs enables scalable, accurate analysis of software, making it a valuable resource for improving software security. Moving forward, enhancing SSLINT to cover additional libraries and emerging threats could further this impact. Okay, so that's today's presentation. Thank you.